What if humans had night vision? Imagine walking down a city street after dark and seeing everything around you as clearly as during the day. No lights, no shadows, no fear. What would that look like? If you've ever stayed up late or woken up early, you've probably noticed how difficult it is to see well when there isn't much light. That is because the human eye relies on specialized cells called cones to see colors and details in bright light. However, there are other animals that can see perfectly fine in such conditions. In fact, some creatures even see better at night than during the day. So how do they do it? And what would our world look like if humans also had this ability? How human vision works. Briefly, our eyes have millions of photoreceptor cells called rods and cones and a layer of tissue at the back called the retina. Cones allow us to see colors and fine details, but they need bright light to work well. We have three types of cones that are sensitive to different wavelengths of light, which allows us to perceive a wide range of colors. Rods, on the other hand, are responsible for our vision in dim light. They don't see colors and aren't great at picking out details, but they're much more sensitive than cones. However, our eyes have about 120 million rods and only about 6 million cones. That means our vision in low light conditions is still dominated by our cones, not our rods. Animals like cats and owls have more rods than cones, so they can see better in the dark. Additionally, their eyes have evolved to capture as much light as possible. Cats have vertical pupils that can widen to let in lots of light. They also have a special reflective layer behind their retinas called the tapetum lucidum, which bounces light back through the retina, giving the rods a second chance to absorb photons. Owls have huge pupils and a disc-shaped membrane that blocks direct light from entering their eyes. This forces the light to pass through a lens and then through their retina twice, before being bounced out. The result is an image almost as clear as if they were looking at it in daylight. And yes, owls really do see better at night than during the day. Some nocturnal animals can see infrared or ultraviolet light. For example, many snakes can sense the infrared radiation emitted by warm objects like mammals, helping them to find prey in the dark. While some insects and reptiles, including chameleons, can see ultraviolet light, this ability helps them communicate using UV patterns on their skin. What would change in human physiology? To see in the dark like animals, humans would need some major physiological changes. Here are just a few. First, our eyes would have to get bigger. More surface area would help capture more light, especially if we could see infrared or ultraviolet wavelengths. Second, our retinas would have to be densely packed with rods, similar to nocturnal animals. Third, we might evolve reflective layers like the tapetum lucidum to enhance our night vision. Of course, these changes would require genetic modifications. Humans would need new genes that code for proteins like rhodopsin, which is found in the rod cells of nocturnal animals. These genes would come from other organisms, perhaps from single-celled algae or bacteria that live in extreme environments and are used to capturing small amounts of light. Through natural selection, these genes could evolve into new proteins that work well in human cells. Once inside our bodies, they could then direct the production of rod-like photoreceptors. But wait, there's more. In addition to changes within our eyes, our entire nervous system would need to change to process the extra visual input. The brain would have to evolve to interpret images with a much higher resolution than the current 128 pixels per degree squared. This may not sound like much, but it's about 10 times better than modern cameras. To make this work, the optic nerve would need to carry signals from the eyes to the brain much faster. Additionally, neurons in the brain itself would have to become more sensitive to detect faint signals. In the absence of much light, all of this would require countless genetic changes that would take hundreds of thousands of years to occur naturally. But if humans intentionally introduce these genes via gene editing techniques like CRISPR, evolution could be sped up dramatically. But the most significant change wouldn't be the physiological one. If we lost our color vision and our ability to see fine details in the dark, our brains would need to completely rewire themselves to interpret these changes. Some parts of the brain might shrink while others grow. Also, we'd probably lose the ability to read and write, at least until we develop new systems of communication. How would society change? Seeing in the dark would bring about some major changes to society. Streetlights would probably become unnecessary, making cities darker and potentially saving billions of dollars in electricity costs. Traveling and working at night would be no different than during the day, which could lead to longer work hours and increased productivity. However, this might also increase energy consumption and emissions as more people use their cars or turn on their lights at home during nighttime hours. Additionally, air travel could become more efficient as planes could fly over oceans without needing to wait for daytime hours. Nighttime activities like stargazing, hunting, or fishing might become more popular. And what about crime rates? Would they increase or decrease at night when more people could see? Less light pollution would certainly impact wildlife. Nocturnal animals could suffer if their habits are disrupted by the brightness of city lights. On the other hand, birds that migrate at night could benefit from less light pollution. No fear of the dark. Perhaps the most significant change would be the reduction of our fear of the dark. In many cultures, darkness is associated with evil, danger, and death. Children are often afraid of the dark, and this fear can persist into adulthood. A lack of visibility can trigger anxiety and activate our fight or flight response. This is because our ancestors who lived in darkness couldn't see predators coming until it was too late. So those who were more afraid of the dark were more likely to survive and reproduce. But if humans could see in the dark, our brains would no longer associate darkness with danger. Our psychology would evolve to overcome this fear and anxiety. Benefits and drawbacks. Overall, the benefits of being able to see in the dark would likely outweigh the drawbacks. Better night vision could reduce the number of accidents that occur at night and improve surveillance, making cities safer. It could also prevent many crimes and reduce the number of animals killed by cars. Additionally, people who work night shifts or have trouble sleeping at night due to artificial light wouldn't have to worry about the darkness anymore. However, there are also some potential downsides. For example, more crime might occur at night when more people could see. There is also the possibility of overexposure to darkness, which could disrupt our circadian rhythms and cause other problems. Plus, some people might not want to change. They might prefer the peace and quiet of a dark night with fewer distractions from artificial lights. Could we actually evolve this or enhance it? Although it's unlikely that humans will evolve night vision naturally anytime soon. It might be possible to enhance our night vision through technology or biohacking. Scientists are already developing retinal implants that can restore vision in blind people. With some modifications, these implants could be used to give people better night vision. Another approach is to inject chlorophyll-based enhancers into the eyes, which can improve contrast sensitivity and make it easier to see in dimly lit environments. However, this method is still in its early stages of development and has only been tested on mice so far. At the moment, the best way to see in the dark is to use night vision contact lenses. These lenses contain an infrared sensor that captures images in the dark and then transmits them to a display in front of your eye. The downside is that they're bulky and uncomfortable to wear. But with further development, they could become a common sight, allowing us to explore the world like never before. Cool fantasy or future reality? The idea of humans seeing in the dark is a cool fantasy, but it's probably not going to happen anytime soon. In nature, animals have evolved specialized adaptations to help them survive in their environment. But humans have developed technology and tools that allow us to thrive even in the darkest of places. Seeing in the dark might seem like a useful ability, but it's also possible that we would lose something if night lost its mystery. Darkness is a time for rest and reflection. It's a time to turn off the lights and tune out the noise of the outside world. If we could see in the dark, it's possible that we would lose some of the tranquility that comes with nighttime. There are also practical concerns. If everyone could see in the dark, it would be difficult to coordinate our activities. We rely on darkness to set boundaries between public and private spaces. And it's possible that our social interactions would suffer if everyone could see in the dark. Ultimately, the decision of whether or not to pursue night vision is a societal one. As a species, we need to decide whether the potential benefits are worth the potential risks. For now, though, it seems like night vision is something that belongs in the realm of fantasy rather than reality. Thanks for watching.